Hello everyone, this is Yazan. In this presentation, I will talk briefly about the problem at hand where healthy trajectory generators are subjected to cyber attacks, most probably in the form of false data injection. Utilizing the invariant quantity of the resulting multi-agent trajectory generator system, the defense mechanisms over complete and star graphs are discussed. After that, covert attacks and possible detection and mitigation defense mechanisms are discussed. Then simulation results will be discussed, followed by some concluding remarks. Starting with the clock synchronized and distributed trajectory generators given in the form of a multi-agent system with finite numbers of agents, the dynamics of the ith agent in the tau direction is given in the first equation over here. Utilizing the linear diffusive coupling protocol over a communication network, we can write the dynamics of the trajectory generator multi-agent system as shown to the upper right over here. The main idea is to build a distributed trajectory generator system over a communication graph characterized by the graph Laplacian matrix. This results in an average consensus behavior whose invariant quantity must be held fixed regardless of any cyber attacks that may take place during operation. To ensure the invariance of the consensus values at each time instance, its time derivative must be zero. We propose the equation shown at the lower left over here, which after simplification yields the equation at the multi-agent system level bounded here by this box. Now it's required to decompose it to the agent level based on the communication graph available, such that suitable defense mechanisms can be realized. For example, over a complete graph, this equation can be equally decomposed at the agent level as shown over here. This decomposition gives rise to the first line of defense proposed in this paper. Similarly, over the other graph investigated in this study, i.e. the star graph, the previous equation can be decomposed at the level of the central agent and at the level of eternal agent as shown here, such that the first line of defense is realized over a star graph as well. Unfortunately, the first line of defense can be breached if the attack is covert and is manifested using the dynamics shown over here. This covert attack can be initiated at the agent level or at the multi-agent system level. To add another level of defense, the second line of defense is proposed, where after the invariant quantity is locked, each agent can undergo self-check against the transmitted data, and the results can be used to reconcile and mitigate the value of the affected states. Note that the detection mechanism can be as simple as the one shown over here, for example. To demonstrate the proposed detection and mitigation mechanism, consider a trajectory generator multi-agent system over a complete and star graph as shown over here. The attacker intention is to kidnap the agents or divert them from reaching their target point at 5. The defense mechanism over the two graphs successfully detects the attack and maintains the consensus value invariant as desired. As a conclusion in this investigation, an efficient approach to detect and mitigate cyber attacks was presented. This approach utilized the fact that the behavior of a leaderless multi-agent system is already determined through the available initial conditions. Two lines of defenses, first and second, constituted the core of the defense mechanism. The first line of defense detected to an extent the tampering attempts to change the invariant quantity, and therefore the goal of the multi-agent system. The second line of defense was mainly interested in the variation that occurred at the trajectory level, even if the same invariant quantity was achieved. Combining both lines of defenses resulted in an immune consensus behavior of the multi-agent system under study. The proposed approach enabled the intention behind the attack to be clearly identified, which could be beneficial in revealing the identity of the attacker as well. More sophisticated methods to initiate the cyber attack will be investigated to highlight any vulnerable points of the proposed defense mechanism. Thank you.